RHS Pre-calculus presents Complex Numbers with C and Friends. In this clip, you will learn about complex numbers. A complex number is usually represented in its standard form, Z equals A plus BI. In this equation, A represents real numbers and B is a coefficient of the imaginary number.
First, we will look at how to simplify complex numbers. Given that I is equal to the square root of -1, we can find the exact value of I to the power of any exponent. I to the 0th equals 1, and I to the 1st equals I. Given the definition of I squared is -1. I cubed can be written as I squared times I, or -1 times I, and reduced to -I. Lastly, I to the power of 4 is the same as I squared times I squared, or -1 times -1, and simplified to +1. The value of all exponents above the 4th power of I can be determined by finding whether 1, 2, 3, or 4 is the greatest denominator. Next, the complex conjugate of a complex number can be calculated. It is simply the complex number with the imaginary value with an opposite sign. Now we will move on to adding and subtracting complex numbers. First, we will look at adding. The first step is adding A together. Next, we will add B together. The I will just stay in the same place after B. Finally, write the equation in standard form. Let's try an example. 5 plus 2i plus 4 plus 3i. We will begin by adding the A, which is 5 plus 4, which equals 9. Then we will add the B, which is 2 plus 3, which equals 5. After rewriting the equation in standard form, we get the final answer, 9 plus 5i. Next, we will learn how to subtract complex numbers. The first step is subtracting the first A from the second A. Next, we will subtract the first B from the second B. The I will still stay in the same place after B. Finally, write the equation in standard form. Let's try an example. 7 plus 4i minus 3 plus 2i. We will begin by subtracting the A, which is 7 minus 3, which equals 4. Then we will subtract the B, which is 4 minus 2, which equals 2. After rewriting the equation in standard form, we get the final answer, 4 plus 2i. Next, we will look at multiplying and dividing complex numbers. In order to multiply two complex numbers, you must use the FOIL method, first, outer, inner, last. For example, look at this problem. 3 plus 2i times 5 plus 8i. First, multiply the first two terms, 3 and 5, which is 15. Then multiply 3 by 8i, outer, which is 24i. Then multiply 2i times 5, which is 10i. And finally, multiply 2i by 8i. Be careful here, because I times I is -1, so this becomes -16. Therefore, the expression simplifies to -1 plus 34i. In order to divide two complex numbers, you must multiply the expression by the conjugate of the denominator. For example, look at this problem. 4 plus 6i divided by 10 plus 2i. You must multiply the entire expression by 10 minus 2i, which is the conjugate of the denominator. This will allow you to remove I from the denominator. Then FOIL both the numerator and the denominator. The -20i plus 20i on the bottom cancels out, and this can be simplified to 52 plus 52i divided by 104, which equals 1/2 plus 1/2i. Finally, we will look at graphing. When graphing complex numbers, remember that the x-axis represents real numbers, and the y-axis represents imaginary numbers. So to graph the complex number -4 plus 7i, place the x value as -4 and the y value at 7. The graphed point should have coordinates of -4, 7.
Complex numbers have many practical applications and are necessary for advanced math classes. We hope this video has educated you to the uses of complex numbers. Thank you for watching Complex Numbers with C and Friends.